The grid shows the graph of y equals cos x for x from 0 to 360 degrees. A. Solve the equation 3 cos x equals 1 for x from 0 to 360 degrees. Give your answers correct to one decimal place. Some of you might be confused with this question because usually you only solve trigonometry with triangles and shapes. However, you do know how to solve this question. If you consider the triangle with angle x, the adjacent side is 5 and the hypotenuse side is 7. This means that cos x equals 5 over 7, and you can easily solve for x by doing inverse cos of 5 over 7. So when you want to solve 3 cos x equals 1, all you need to do is make cos x the subject of the formula first. Then you can solve for x using inverse cos. The inverse cos of 1 over 3 is 70.5. This means that one of our answers is 70.5. However, if you look at where we're supposed to write the answer, there's another place for another answer. So we need to find the other answer that works for this equation as well. When we press inverse cos of 1 over 3 on the calculator, what it does is it goes to 1 over 3 on the y-axis of the graph of y equals cos x, draws a straight line, hits the graph, then gives us the corresponding x value for that value, which in this case is 70.5. However, if you continue that straight line, because the graph of cos x repeats itself, it should also hit the graph at another point, and the corresponding x value for this other point is our other answer. The graph of y equals cos x is symmetrical along 180, so if the first answer is 70.5 from 0, then our second answer should be 70.5 from 360. Therefore, the other answer should be 360 minus 70.5. If you're unsure about the second angle in your answer, you can always substitute back into the equation. This means that if we substitute back cos 289.5, it should give us an answer roughly equal to 1 over 3, and we can use our calculator to do that. It roughly equals 1 over 3, and therefore our answer is correct. B. On the same grid, sketch the graph of y equals sine x for x from 0 to 360. You should roughly remember what the sine and the cos graph looks like. However, if you don't, you can always substitute in the coordinates and then plot them manually. For example, just substitute in the main coordinates like 0, 90, 180, 270, and 360, and then join the dots or join the coordinates with a smooth curve.